So I'll start as I've always started these things with an outline of what the mission is all about. We have the AI tsunami coming, and a lot of managers, people who work in offices doing standard operating procedures and spreadsheeting and so on are starting to see this tsunami coming. I have some friends who've already started losing parts of their job or all of their job and so on. So this AI is coming, and people are concerned that, yeah, the work they're doing is going to go away and the jobs they have. And so what I'm trying to do is figure a way to help people to, instead of being under the tsunami, to be up here, not just surviving the wave, but thriving. And so the big question is, how do you get from down here to being up here? And that was a question that bugged me some time ago. And then I started working on various AI projects for my clients. I didn't really like this thing of what everybody called prompt engineering, because it didn't feel like engineering. It was all a bit squishy and hallucinations, and the AI was unpredictable and everything. But little by little, I started to find that there were things that, as somebody who does automations in business for a living, this whole thing of being able to create AI agents, wasn't impossible. In fact, it ended up being something that people like me were pretty well qualified to do. And the bedrock of the whole thing is to start down here at the bottom with what we call the standard operating procedures. And then on top of that, we start to build automations that automate those standard operating procedures. And we did most of that either using spreadsheets or no code. And the thing about no code is that it uses similar technology to spreadsheets. So everything I learned about formulas and columns and rows and tables and lookups and macros and all of that was applicable to using these no code tools like Notion and Airtable and my favorite Coda. And within that technology, there are three pillars that we use to build these automations. And the first one is the data. And the second pillar is all about the business logic. And the third pillar is when you give your users some kind of user interface. And of course, for building the data and structuring it and getting it all to work, we're talking about tables and all the logic. Many of us have years and years of doing formulas. And the great thing about spreadsheet formulas and no-code formulas is that every time the inputs to the formulas change, the system automatically recalculates them. And it means that you can set up the logic in a very definitive way, a passive way. And every time the data changes, your system responds to that because it's got the formulas. And when it comes to doing UI stuff, then we're pretty experienced in the spreadsheet world of building forms and getting users to type in fields, to add rows, to click on buttons, and so on. So the technology to automate our processes is stuff that, we've had for quite a while. But when you start moving into the world of AI, the other thing that we have that's needed, that most managers in the back office are very good at, is knowledge base. All those documents that we've been writing for years, the how-tos, the checklists, the policies, the procedures, the training documents, we can hand all of those over to the AI system when we automate our processes, and it gobbles them up and it uses them. And it needs people like us who are able to manage those documents, create those documents, and curate all of that knowledge and all of that management. And so the bit that goes on the top to make all of this a new career, a new powerful position within the organization, is when we start building AI agents. So Most business managers know how to do SOPs, they know how to do data, they know how to build formulas, they've had experience with doing UIs, and they know all about this knowledge management. And the bit that's missing is, how do we build agents? And it turns out you build agents the same way as you build spreadsheets and the same way you build no code. You have tables, you have formulas, and then the new thing is you have prompts. And that means we have to start getting good at building prompts. And so my earlier workshops were all about how you can build these things as tables that have within them AI columns and they become agents. And then the prompting, I did a workshop on precision AI, which was all about where to use prompts and how to use prompts. And so now I want to go to the very highest level of using AI, not just to automate our no code and spreadsheet workflows, but to actually use AI to generate these automations. And that's where we have to start writing specifications in such a way that the AI can understand them. So for your standard operating procedures, there are techniques out there, and the one that works the best in my experience is a thing called business process management notation, BPMN. And it's a way of describing in a very precise way how a business process is meant to work. And if you design your BPMN the right way, an AI will also be able to understand it just as well as a human. And then, as I said, for building the automations, we're able to provide all the usual stuff. We have to define the tables, we have to define the business logic, we have to define the user interface and the workflow that connects them together. The knowledge base is easy because that's something we do quite a lot of, and that's docs. And then when it comes to doing the AI, I've done a workshop about that. Now, the AI, the large language models that we have today, amplify our own thinking and our own clarity. If you're wishy-washy and fuzzy and not terribly clear, then you'll get something mediocre. But what I've discovered is that if we can be extremely precise in defining what it is we want the AI to do and figure out techniques for improving that precision, it amplifies enormously how well we're able to solve problems with AI. And I have seen it again and again. It will quite literally 10x the results you get if you can manage to be extremely precise. So when I'm working with clients and business managers to define what a business process is and how we're going to automate it, even before AI came along, people would stand up and start drawing diagrams on the whiteboard. So you get somebody standing up, and those diagrams tended to be boxes or blobs of one kind or another, and then they would put arrows between them and say, this is what we're going to do. And then somebody else would come along and they'd say, yes, but then there's also this and this and this, and then this can go to here, and then that might go to there, otherwise it might go down to here. And then you have somebody else coming along and they say, well, then of course you've got these three things happening, and this happens first and that happens next. And when that's done, then it goes to here. And eventually I started to realize that without some kind of strict policy, everybody is using blobs to mean different things and arrows to mean different things. So this person meant this to be a process and this to be a data flow. But then somebody else comes along and says, well, this is a table in a database and this is a relationship between the tables. Then somebody else comes along and says, these are events and these arrows represent a sequence. This happens first, that happens next. And somebody else says, these are states and these are transitions from one state to another. In other words, without some kind of discipline, we can end up with ambiguity in our diagrams. And so we need to have a degree of precision in how we write our diagrams in our own heads so that we can communicate with ourselves. We can communicate with other people, we can collaborate with others. And nowadays, particularly because it helps to be able to provide these clarity of thought to the AI system if we're going to use it for vibe coding or vibe building. And the example I like to use when I'm thinking about this is if I want to build a house, I get an architect, and the architect does a drawing, and they'll do a plan of what the floor is going to look like. And then, of course, they'll do another drawing over here, which is the end view. And so it doesn't take one diagram, but three diagrams to give us a view of the house so that you can take measurements. So you have the plan, the end view, the elevation. But then the plumber comes along and says, well, we're going to have a cold water tank and a water heater, and we're going to have a pipe coming in here, and we're going to have a valve here, and we're going to have a boiler down here, and we're going to have radiators. And so they draw a diagram where each of the lines represents pipes and plumbing and all kinds of stuff. Not the same language that they're using for this diagram, but a different one. And then the electrician comes along and says, well, we'll have a fuse box here, we'll have various breakers and switches and bulbs and so on. So what they end up drawing is very different. You don't use the same language for the electrics that you use for drawing the diagrams of the plumbing, and you use a different language for the diagram that you're drawing over here. But you need all of these in order to be able to be clear and precise and complete about the house you're going to build. And so I went off to find out how we can build better diagrams, and discovered that in large corporations where they have big IT departments, they have people who have been doing this for decades. And over those decades, they have developed a very precise and clear way of documenting how systems work. And I went off and figured out how three of those diagrams in particular can be used to automate any given process. So the first one that gave me clarity of thought, and I've said it before, that it was like getting a new pair of X-ray glasses, that when you put them on, suddenly I could see clearly. I had a brain that would slice through problems, and I could communicate clearly, and everything started to make sense. So the first such diagram is one where you say, we're going to look at the business objects that are in our process. For example, we have customers, and in our business process, we also have products. And now what I want to do is model how customers and products interact with each other. And we're starting to get into building what is known in the business as an entity relationship diagram, where we're looking at what's the relationship between these two. So each customer can order lots of products, and we represent that with this crow's foot, which means one customer can have lots of products. But if you go the other way, it's saying each product can be ordered by only one customer. And that doesn't make sense. So in fact, the truth is that any one product could be ordered by lots of customers, and any one customer could order lots of products. And this gives us the first rule that we have to be able to follow when it comes to looking at entity relationship diagrams, and that is, this is known as a many-to-many. And many-to-many doesn't work. It's not that it's technically impossible to make it, it's that when you have a many-to-many relationship, it's just you've nowhere to store the information about these relationships, and therefore we have a golden rule that says we don't allow many-to-many relationships because they're nothing but trouble. And it also means that we're missing something. There's something out there that we're missing that helps us form the relationship between customers and products. And it doesn't take a genius to go and figure out that that is the idea of an order. So what we're saying is each customer can place many orders. But if we reverse the relationship, each order belongs to only one customer. And that's right. That makes sense. And then each order comes along and can have several products in it. Seems to make sense. But then when we look at the relationship backwards, each product can actually belong to many orders. So we haven't quite solved the problem yet. We still have a many-to-many relationship. But as I said, this is telling us that we've missed an object. There's something else in our business process that we've missed. And we need to figure out what that is. Well, if you take out an order and look at it very closely, you'll see that it actually has multiple line items in the order. So when we create an order, that order can have one or more or many items. But each item only belongs to one order. So that makes sense. And as I said, each order only belongs to one customer. So that makes sense. So these two are making sense. And each item represents a single product. So yes, each product can belong to many line items, but we have a line item that sits in the middle here. Each line item belongs to one order. Each line item references a single product. And so now we have a model of the data that makes sense. And you can go off and study books on third normal form and relational database theory, but in fact, this is the essence, the most important piece we need to figure out, is we can build our data model by finding the objects in the real world that we need to model in our automated system, and then work out the relationship such that we have crow's feet. We only have a one-to-many, or in the reverse, a many-to-one relationship between all of our different objects. Now, sometimes you might say, well, a customer has an address, and they've only got one address. In which case, you could argue, well, the address doesn't belong as a separate object, a separate table. You just put the address inside the customer table, and there's no need. The only reason you would create a separate relationship and a separate table for addresses if you said, listen, we're just like Amazon. We have multiple delivery addresses for each customer. In that case, you've got to build a one-to-many. And once I figured out how to do this and got practice doing it, it meant that I could apparently walk on water. People were getting confused and bemuddled. They had processes that when they started expanding them were starting to break and they couldn't figure out why. And I was able to come along and draw diagrams like this and clarify the whole thing. So I'll give an example of one that happened only recently. An organization was building an automation for hiring people. So they had people and they had jobs. They made a table for the people and a table for the jobs. And so each job could have many people applying for it. And that worked very well until after 6 months, somebody applied for 2 jobs. And they literally couldn't figure out what was wrong. They actually created 2 records for the same person and put the name of the job in square brackets after the person's name. Don't know what it is about square brackets, but people resort to putting things in square brackets when they don't know what else to do. But of course, the problem was that this is telling us we're missing an object. Something in our model is missing. We don't know what it is, but we know it's there. We have to go looking for it. And the thing that was missing was an application. Each job can have many applicants, but each applicant is just a single person. But a person can apply for many jobs. And they had the concept that every person somewhere inside this, they had the date of the interview that they attended. And then, of course, somebody decided to call this person back for a second interview. And that didn't work because they were assuming there was only one interview per person. And that meant that for every application, it was possible to have many interviews. And once we changed the tables to represent that, suddenly the whole thing worked. But they weren't able to figure that out because they had no concept of how to model the data. So coming back up here to our thing, this is the modeling of the data. And if you have the tools to think clearly and describe precisely the data objects that are in your workflow, then you're able to overcome these difficulties and develop a system that maps very closely what's happening in the real world. And so I'm going to start using diagrams to illustrate that. But while I'm switching from one system to another, I'll pause and see if there's any questions.
No questions from me, but thank you.
Okay.
Oh, no, no questions, but I'm loving this.
Blessing, I hadn't spotted you coming on board. I'm working off my little laptop and I
I'll
don't have
show you my
multiple
face.
screens, so I can't. Hello, Happy New Year. Good to see
Happy New
you.
Year's. Good to see you. I am loving this. I just took some of your videos on YouTube and your course, and I sent it to my husband because as much as I talk at him about AI, and he works on a data team at an oil and gas company, these are the conversations. These are the exact
Yes.
conversations. And I'm like, Max is going to give you the crash course. So I'm loving it. I'm loving it.
I am delighted to hear that. I recommended it to my husband. Higher praise than this you do not
Yes.
get in this business. Thank you very
Yes.
much. Okay. Now, okay, okay. Let me just go on to full screen and okay. So I'm going to model a set of data elements for an application that I built here in Greece. There's a hardware company that has taken over the building industry on all the islands around the Aegean Sea. And basically, what they've built is a kind of Uber for builders and plumbers and people who are doing woodwork and shipbuilding and so on. So you phone in what it is you want, and they will find a truck driver or a van driver in your neighborhood who will drive to the depot, pick up all the stuff, and drive to wherever you are and deliver it. And it has taken off, and they've expanded the number of depots all around the islands, and it has really taken off. And so they needed to automate this, and we got to work on it. And they've done it with Coda, but they could have done it with any of the no-code tools. So what I'm going to do is start off and say that one object that we have in every system is an object that represents each of the types of users who are going to use the system. And the first type of user that they need to deal with is the client. So I have a little table. If I can just, I can never type when somebody's watching me. So you all stop watching me there for a minute and I can type. Okay, so we have a client. And in fact, I've already made a mistake because I put these in plural. You either go singular for everything or plural for everything, but don't mix them up or you'll get yourself confused. So we have clients. The other user type we have is the drivers. And then the next type of user that we have is the admins who actually process things in the back office. And what I've done here with this is I've put in the necessary formulas to generate the code that will do mermaid diagrams. So mermaid is a system that draws diagrams. And one of the diagrams that it's able to draw is these. And this is called an object model. Now, it doesn't use the crow's feet. In fact, it uses a blob instead. So clients, and have the first column here, is they have many things. A one-to-many relationship, what they can do is they can place orders. And I'm starting to build a model of the objects. It's not terribly interesting at the moment. We'll add a few more things to it. Because the other thing that our clients have in this system is each client has multiple addresses where we can deliver things to them. Orders have multiple line items in them. And this allows us to get over the many-to-many relationship that otherwise would exist between orders and products. And so items have one from the products table. So this is how I create a new table for products. But this is the sort of stuff that I would do on the whiteboard. And if I'm in a client's office and they don't have a whiteboard, I will take out my whiteboard pen and I will go to the window and I will use the windows as whiteboards because you got to have a whiteboard. So we have this situation where we're saying that clients have many addresses, they have many orders. Each order has many items, but each item has only one product. We need to talk about the drivers. Each driver belongs to one of the regions. So whenever an order comes in where the delivery address is for a given region and that region has a driver, that's how we know how to assign it to the driver. And that means that every address has a link to one of the regions. And that means we need a table that defines what the regions are. And then every time somebody sets up an address, they say which region it belongs to. And every time we set up a new driver, we say what region the driver operates in. And that way we can match up the orders with the drivers whenever somebody comes in and puts in a new order. Now, the items refer to products. And so we can start to say something about the information that's in a product. So we can say that we have a product ID number, we have a description, text, each product will have a price, all kinds of other data, but for the purpose of this demo, I'm just going to put a few things in there. We're going to keep information on all of our users, and so I put in the data items for the users. They will have a name, they'll have an email address, they will have a telephone number, and of course, they'll have a user ID. I learned a long time ago to always give everything its own unique ID. No code doesn't insist that you do, but you allow your data tables to just use a person's name, then what happens when you have two people of the same name? Email address, yeah, you can use that, but it's much better to be giving product IDs and order numbers and stuff like that. Now, whenever somebody is adding an item to an order, this is where we want to be able to say that we're going to store the quantity. So we've already said that each item refers to a single product. We want to store the product. And we probably want to compute the order amount. So there's an order amount that's got a dollar sign on it to make it a currency. We're going to say that administrators operate the region. So every region has an administrator that is responsible for that region. So if I go up here to the regions, regions has one record from the admins table. Now I'm flying through this. In the proper training, we take longer, we do a lot more examples. But the illustration I'm trying to make here is that the questions I ask the business people, there's only 3 questions. What are the objects that are out there in the real world that we're going to have to model in the computer system in order for us to be able to automate your solution? And then for each of those objects, what is it connected to in a one-to-many relationship, and what is it connected to in a many-to-one relationship? And then at least give some initial understanding of what are the data items that are going to be in that object. And obviously this allows us to build our tables. But I don't dive in straight away in any of the no-code tools and start creating tables and adding a bit here and adding a bit there and so on, because I would much rather start this whole thing out with a clear object model of what's related to what. This is simple, it's clean, and it's fairly straightforward. So we have a table of users, and we have clients who have multiple addresses. We have clients placing multiple orders. Each order consists of many items, but each item only has one product. And we also have drivers. Each driver belongs to a single region. See, that's many to one, which means one driver has one region, but each region can have many drivers. Each address belongs to a region. Each region has an administrator who looks after all of the details of the drivers and so on that are operating in that region. So within a few minutes, I'm able to pull together a diagram that represents all of the objects in our model with the right relationships. And because I've also started to indicate what data items are in there, because that's the third question you ask is, okay, what are the main items of data we want to put in here? And that allows us then to come up with the next diagram, which is the same as the object model, except that it provides more information, right? So in an entity relationship diagram, you have a box for each of the tables, and then we have sub boxes for the things that are in it. So here's the clients. It has a link to many orders, a link to many addresses, a link to one user. So in Notion and Airtable and in Coda, we would be able to encode those things using whatever the terminology is of the particular product that we're using. But the overall concept is pretty well defined here. Right, so products have a link to all the items that they occur in. They have a number, which is their ID. There's a text, which is their description, and a currency item, which is the price. Each order has a link to many items, but it only has a link to one client. And the items have a link to one product. They have a link to the order that they belong to. There's a number, which is the quantity of this particular product that's on this line item. And then we have a currency, which is the amount, which we'll be able to put in the arithmetic that says it's the price multiplied by the quantity, and we can stick in a formula there if that's what we want to do. We're saying that clients have many orders, but they have many addresses, and an address belongs to a single region, and it belongs to a single client. Each driver belongs to a single region. Each of the regions has many drivers, and it will also have many addresses within that region. But each region has only one administrator. So by filling out these questions, the 4 questions, what are the objects? Which objects are linked to many of some other object? Which objects are linked to just one of another object? And what are the major data items we need to think about? I have already built a significant amount of modeling. And if I hand this over to a competent no-code builder, they'll be able to build a database. Or if I hand it over to an AI that has access to the right tools, it can build me a database. I can say to an AI, give me the SQL script that'll create this database. Or I can say, go to the Coda MCP and get it to build the tables in a Coda document that represents all of this. And so my clarity of thought means that I no longer get confused. And if somebody throws in a new object that we have no idea how to handle, I fit it in here somewhere. So somebody says, okay, we do invoicing every month. Where does the invoice fit in? And so I say, well, are you going to invoice for each order? Or are you going to do a monthly invoice for each client? And it turns out this was what happened with these people. They actually invoice per item because some items get delivered and some don't. Some get delivered and then get returned back again. Those 4 tons of bricks you gave me were the wrong color. Or I only used 1 ton of those bricks. So I'm giving you a ton back and you invoice me for the difference. We tried originally to do that on an order by order basis. And the discounting didn't work and the invoicing didn't match the quotations that were going out. And so we said, what's missing is the items. Some items get delivered, some don't get delivered, some are on back order and they don't get delivered till next month. We can't invoice for them. So when we came time to put in the invoicing, we were able to gather around this diagram and have a meaningful conversation about where do we fit it in to this model. So now I'm going to pause and see if anybody's got any questions. Okie dokie. Let's go and look at the next diagram that we're going to work on, which is the workflow. So basically, I have, and I'm going to just get rid of any of these things that are there from before. Okay, so now to figure out the workflow is saying if I log in as a client, what am I going to see? If I log in as a administrator, what am I going to see? And I'm going to start by saying if I log in as a client, I should be able to add new addresses. So the first question is, what is this person allowed to add? If I log in as a client, they can add addresses and they can also create orders, right? If they're looking at their list of addresses and their list of orders, they can select one of each of those and go and do some processing on it. So they can select an order and go and work on the order, or they can select an address and go and work on the address. Clients, what do they search for? Well, I'm going to say that they search for products, right? So when they're searching for a product, what fields do they use? Well, they can search for the product using description. They can search for the product using the product category. And let's just, for the hell of it, say they can search based on price. They can give a maximum price and a minimum price and a category and say, show me all the gravel you have that's between this price per ton and that price per ton, right? And what this has done is it started to give us a workflow diagram that says, if I log in as a client, I can search for products. I go into a screen that shows me those things that I can search for, the criteria, which will bring me up a list, and I can click one of the items on the list, and then I'm in the products screen. Similarly, I can instead say I want to create a new address, and it takes me to the address dialog, and I can put in the details for the address, or it's showing me all my existing addresses. I can select an address and edit it. So each of these gray blobs is in fact a button that appears on the screen. So I have a button called Search Products. I have a button called New Address. If I have addresses, they will appear on my screen, and each one of them has a button that is to select that address. And when I click those buttons, I end up with the dialog that allows me to modify addresses. The same is true, I can create a new order, or if I have a bunch of orders already there, I can select an order and it will take me to the orders dialog. So we're going to go through this now for a whole series of objects, and to save time, as they say in all the best cookery programs, here's one I did earlier. So the object model I already did, right? I filled in all of these different columns for my object model, or I walked up to the whiteboard and I just drew this beautiful diagram using pencil and paper or whiteboard marker or whatever, right? And it says that clients have multiple addresses, they can place multiple orders, each order is connected with a single driver because the address that I'm sending the order to belongs to a region, and a region has multiple drivers, and at some point the system is going to assign a driver to the order. Order has multiple items, but each item has only one product. And then there are these other tables that get created where you enter in your criteria for searching for orders. And this table is where we enter in criteria for searching for products. And so this gives us all of the objects in our database. Each one of these is a table. And the relationship tells us what sort of links we need to put in to those tables. And then we end up with the much bigger entity relationship diagram that tells very precisely how to build this database, right? So we're going to put these fields into a client, we're going to put these fields into the orders, we're going to put these columns into our products, and each item has these. Can we just check that everybody's left anybody behind in the dust? You understand where I am and what's happening here, yeah? So the next thing that I'm trying to get the system to understand is who logs in, and when they log in, what can they do? So I fill out this table here. So I was chatting away, and you couldn't see that this is the table that we're talking about, which is the workflow model. So for every object, I'm saying, what can they add? What can they select? What can they search? Who's allowed to edit that particular object? And if it's a search, what are the search criteria that we're going to use for searching for that? So products, when I'm looking at a product, if I've searched for a product using the category and description, and I have a product in front of me, I can add it as an item to the items table. If I'm looking at an order, I can add items to the order, but only the clients are allowed to do the editing. Clients are also allowed to change their addresses. Nobody else can mess with their addresses, and everything else is for the admin person to work on. So a client comes in and they can add orders, they can add addresses. If they already have orders, they'll see them and they can select an order and modify it. If they have addresses already, they'll see the addresses, they can select an address and they can modify it. Or they can search for a product. And this gives us this workflow diagram where each of the gray blobs here represents a button or an automation, but usually it's a button on the screen. So I log in as a client. So here's the client logging in to the client document or the client view of the model. And I have a button called Search Products, which takes me to the Search Product dialog or view where I can fill in my search criteria, see a list of products, and then select the product that I want. When I'm looking at the product, I can add it to my items on my current order. I can add a new address, or I can select an existing address and then edit it. This is where we edit addresses. If I'm a client, I can click the button saying create a new order, and I end up in the orders screen, filling in the details for the order. And somewhere in there, there's a button that says add a new item. And then I can go and work on the items. If I'm looking at my existing orders, I can select an order and then I can go and look at that order and if necessary, add new items to it and so on. So this is where we start to flesh out what buttons are needed and what screens are needed to make the workflow work. Now, obviously, we're going to have to add some logic to this to say, well, if you select an order, but the order has already been delivered, well, then you can't go and add a new item to it. You'll have to create a new order to do that. So there's a bit of logic behind these buttons that says when they can and can't do what you're asking them to do. But we've started to get a feel for how the workflow is going to go for our application when it's up and running. So if I log in as a driver, I can select orders that I'm going to deliver. Or administrators can select orders. They can search for orders. And when they have an order, they're allowed to go and make changes to the order if the customer has reported a problem with their order and so on. So this is the workflow starting to emerge from the decisions that we've made in this matrix here. So now I'll stop and ask if there's any questions before I carry on. Okay. So let's now go to the next thing, which is the business logic. Actually, I need to go to the process model. Okay, so we have a table that we use for getting into the real nitty-gritty of how the process works. And this is where for every object, we're going to say, what are the different states that that object can be in? Usually this is represented by a column in the table called status. So projects have a status, and tasks have a status, and orders have a status, and the items within the order have a status. And I'm sure drivers have statuses where they're either at work or on vacation and so on. Addresses might be active or suspended, but I'm not going to worry about that. I'm only going to work on the orders and the items. So the different statuses that an order can be in is that it has just been created, but it hasn't yet been confirmed. Then it can go to the state where the user has confirmed it. It can be invoiced later on, and the invoice gets paid. It moves to the order being paid. But if they don't pay it and the 30 days or whatever lapses, it switches to the status of being overdue. After it's been confirmed and the driver has picked it up and delivered all of the items on it, it goes to dispatched, which is saying that it has been delivered. And then on the items, an item can be available. The product has been assigned to this order, and so it's available for the driver to go and pick it up. Or it can be unavailable, in which case it may have to go on a back order or get moved from one depot to another. When the user has built the order, they go through confirming each of the items. So it can be in a confirmed status. If the driver has picked it up, it's in a collected status. And it can either be delivered or it can be returned. So one of the things that it shouldn't be, I'm going to remove that particular state from there because I think that was something I added in later. Okay, so we now need to tell the system how you're allowed to go from one state to another. And this is the real nitty-gritty of the logic of the business process. So we have a set of transitions, and a transition has 4 words. We give the transition a name, which will be the label that will appear on the button. We'll say what status it comes from and what status it goes to for the particular object that we're on the column, on the row of, and then we give who's allowed to do it. So the confirm button will take an order that's been created and turn it into a confirmed order, and it can only be clicked by the client. The shipped button is done by the system. There's a system that runs in the background, so it's an automation, and it looks to see which orders have been dispatched. And the reason is because it looks to see have all of the items been moved and delivered. And when that happens, the system kicks in and says, okay, so this order has been dispatched. The administrator has a button called invoice, which will move an order from dispatched to invoiced. Again, the system on a particular date will look at all the orders, and those that are overdue, it'll say they're late. So they'll move it from invoiced to overdue. The other transition is when a payment comes in, the administrator can go and take an invoiced order and mark it as paid. And if a order is in an overdue state, but a late payment comes in, the administrator can move it from overdue to paid. And then when we look at the items, the client can see that that the product is available, so they can confirm it. So it'll move from available to confirmed. The driver can then say, I'm collecting this item, and it will go from confirmed to collected. The driver can say, this item was collected, and I've now delivered it. So I'm moving it from collected to delivered. So there's a single button attached to the item that the driver can see. And when they click on that button, it will move it from collected to delivered. But that button is only visible if I'm a driver. It's only visible if I'm looking at items that are collected. Similarly, a driver can say, I collected this item, but when I got to the address, there was nobody there. The site was locked up. They'd all gone for coffee or something. And so I wasn't able to deliver. So I click the undelivered button and it moves to an undelivered state. Similarly, the driver can say, I've taken this item back to the depot and I click on the returned button. So this item is now not in my van anymore. It's back in the depot and it has been returned. And then an administrator can come along and see that a returned item is there. So they click a button called accepted, and it changes the status from returned to available. Now, it gets a bit tedious, but we tend to only have to go into this level of detail for a few of the objects that really are at the crux of the logic of the application that we're building. And to see how all of this then gets reflected in our diagram, we go up here and we look at the diagram. And so here we're looking at the object called orders. And we see here that orders start in the created state. A client can click a button called confirm and turn it into a confirm order. Later, the system will detect that all of the items that were in that order have been shipped. And so it becomes a dispatched order, which then means that an administrator can click a button to say it's time to invoice. And that creates an invoiced order. After a period of time, the system will flag it as being late, in which case it flips over to becoming an overdue order. And then if the customer decides to give a payment, the administrator will click a late payment button and it'll turn it into a paid order. Or if they pay it on time, the administrator clicks the payment button and it becomes a paid order. Similarly, the items in an order, and this is where we discovered that we needed to do this logic on an item by item basis, not an order by order basis. You start off with an available item. The client hits a button to say, yep, I'm confirming my order. So that becomes a confirmed item. A driver comes along to a depot and says, yeah, I'm collecting this item to deliver. It becomes a collected item. If the driver can't deliver it, they click the undelivered button and it becomes an undelivered item. But if they can deliver it, they click the delivered button and it becomes a delivered item, which is the last state. An undelivered item, when they get back to the depot, they click the return button and it becomes a returned item. It stays as a returned item until an administrator says, oh, I've got some returned items here. Let me click the accepted. And then they are returned to the stock control system as an available item. So these are known as state transition diagrams. They're slightly more restricted than workflows because you move from one thing to another by clicking a button or by running an automation via the system. And we tend to call these finite state models because there's a fixed number of states and a fixed number of transitions between them. And so you'll often hear these referred to as FSMs or finite state models. And this allows us to model the nitty-gritty of the logic. So we end up with one big hairy model here that has people logging in as the driver, selecting an order. We have people logging in as the client and saying they want to create a new order, which is hidden in the back here, new order, and I'm going to add a new item. The item starts off being available. And so in here, we've got all of the logic to implement the process that we have agreed needs to be implemented. But to make life easy, here's a simple table that allows us to capture all of this. And then I have formulas in the background that converts all of this into the necessary code that makes Mermaid generate the diagrams. And my point is, at the end of all of this, I can go to our diagram section and say, if I am hired by a client to automate something, and I go through this process and I say to them, here's your diagrams, right? Here's your workflow diagram, your object model, your database model, and your process model. Then they can take those diagrams to any competent builder of automated systems, and they should be able to go and build this particular automation. Or, and this is where things are getting interesting these days, we can hand these diagrams over to an AI agent, either a Vibe coder agent or a Vibe builder agent, and say, this defines all the logic very precisely. Now go and build me that. And I don't end up with an endless dialogue saying, well, really, I wanted you to do this. Okay, well, that's not quite what I want, and so on. I'm actually handing over something that's very precise and saying, this is what I want you to build. And if you're good at Coda and I give you these diagrams, you should be able to sit down and within a matter of hours build this. And if you have a good AI agent for vibe making or vibe coding, it should be able to take these diagrams and do it as well. However, humans will take these diagrams and look at them. Your AI system is probably better off looking at a text-based version of these models. And so that's the last thing I'm going to show you is the AI prompt specifications. So what I've done is I've taken the script, the code that Mermaid uses for creating these UML diagrams, Universal Modeling Language it's called, and I actually give these to my agent to say, here's the object model in Mermaid code. And it looks at it and goes, yes, 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 I understand all of that. Okay, here's the entity relationship model in Mermaid code. And it goes, dinka, 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 okay. And then it says, all right, clients have these things, products have those things, orders, yes, I understand that, items, drivers, admins, regions. Okay, yeah, I can build that, no problem. And then I say, okay, here's the UI workflow. People logging in, clicking buttons, seeing screens. This is what I wanted to do. And it'll say, oh, yeah, well, I have recognized this. I've seen millions of these on the internet. So I know what all of this is. And yes, I can certainly do that. And then finally, you say, and this is the process model. And what it has is that when an order is created, it can go to, I have a thing called confirm. It's executed by a client. It goes from created to confirmed and so on. And it goes through this saying, yes, 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 I understand all of that. I can build all of that. And in my next workshop, I'm going to use these with an AI agent that has access to the Coda MCP server. In other words, it's able to tell a Coda document, create a table, give it these columns, give it this logic, and it will be able to create a version of this workflow using these diagrams that I have created. And this then allows me to use the skills that I have to create not a gazillion lines of code I don't understand, but a workflow using a no-code tool that I do understand. I can maintain it. My clients can understand it. My clients can maintain it. And so there you go. So any questions?
Will you be selling your doc?
Actually, I probably could, but I don't think there's a lot of money to be made selling something like that in the crude state that it's in. So no, I will be putting it up for people to be able to download it. The problem is, at the moment, it's a bit finicky. You saw it do a few peculiar things on me there, so I have a bit of ironing out. But yes, I will make the doc available. So if you want the doc, I will make it available. If you want to have a bit of help using the doc, I will sit down with you and take you through all of the machinations for using it. But I'm hoping that as well as being attracted to the doc, I'm promoting the idea that these are the diagrams you can draw. And if you can draw them on a piece of paper or on a whiteboard, they will do you just as good if you're going to build these things manually. Make sense?
For sure. Yeah.
Any other questions or comments, Joost or Rowan?
No other questions, but thank you very much. That was really informative. I've worked for 25 years on the one product, but I'm very much a fly by the seat of my pants person. So and I think I've done a lot of this stuff intuitively, but it's really nice to see it in a really systematized way.
Yeah. I mean, you can study this. I mean, there are degrees that you can take in systems analysis, and there are dozens of diagrams that people use. You don't need them. You only need a small number of tools to be able to make this very clear. Joost, good to see you. So if there are no other questions, I'm going to wrap it up there and stick this up on YouTube and on the school platform. And as I said, the next workshop is going to use the MCP tools from Coda to be able to build this kind of thing based on nothing more than those diagrams. And at least it gets you to the point where you're nearly there. And then you have to go and add a few bits of logic to make it fully executable.
Looking
But
forward
this
to
is
it.
better than trying to prompt an AI system using just plain old English. I mean, if you ask an AI system to make a customer order management system, it'll give you a fairly bland one based on the millions that it has seen. But if you have drivers turning up to pick up orders and then returning some stuff, and you have special cases and so on, you need to be able to describe that to your AI, because otherwise it'll just give you something that looks exactly like what you get with Amazon or Shopify. And these people have tried Shopify and they've tried various other tools, and they never quite did exactly what they wanted them to do. So that's why they ended up wanting to build their own thing. So thank you guys, and we'll do another workshop next week where we go on to the next step. So thank you all very much.